Đó. Hiểu vấn đề này không nhỉ? Cho nên là thông thường những cái đột biến mà nó càng ảnh hưởng đến cái sức sống của carrier thì nó càng thiếu. Bởi vì sao? Bởi vì qua rất nhiều đời thì những cái đột biến này đã được loại ra khỏi quần thể rồi. Những cái đột biến còn tồn tại đến rất nhiều thế hệ sau, thường là những đột biến không quá ảnh hưởng đến cái vitality, cái sự sống còn của cái cá thể mang đột biến đấy. Đó. Thôi, nói đùa tí buổi sáng nó tỉnh ngủ, không có ý chê trách gì cả. Không ai nói rằng là phải chăm học, phải thích chữ nghĩa thì mới thành công, đúng không? Thế cuộc sống cho thấy rồi. Bạn cứ bài học cuộc sống thôi, đấy là không nên coi thường bất cứ ai cả. Có những người bạn của mình ngày xưa mình coi thường vì là bạn ấy thường là đến giờ thi thì quay cóp rồi đi học muộn rồi các thứ. Có thể bạn ấy sẽ không thành công theo cái con đường mà học vấn, có thể là bạn ấy sẽ không thành công theo con đường mà học lên rồi đi làm nghiên cứu rồi đi dạy, nhưng mà người ta có những con đường khác để thành công. Có thể là người ta là có tính quyết đoán hơn, người ta có tính mạo hiểm hơn, người ta sẵn sàng khởi nghiệp, có thể sẵn sàng bắt đầu làm cái gì đó đánh đổi tất cả. Rất nhiều con đường để ra vì trên đất. Các bạn có biết là có gen rốt tin không? Có. Các bạn có thể tra trên mạng một cái công ty tên là công ty Cates. Công ty Cates thuộc công ty Khoa Thương do cô Hồ Huỳnh Thị Dương ở trong Đại học Quốc gia Thành phố Hồ Chí Minh lập ra. Thì công ty này chuyên xét nghiệm gen tất cả các loại từ trâu bò, lợn, gà, chó, mèo, thì cá, tôm cho đến con người. Nên khi mà đưa ra dịch vụ thì người ta có đưa ra một cái dịch vụ xét nghiệm gen cho người. Xét nghiệm gen xem là đứa trẻ này là có trí thông minh về tư duy logic hay có thể có trí thông minh về tưởng tượng không gian. Có những đứa trẻ thì có những cái ưu điểm về mặt thể chất, đúng không? Khi độ chính xác đến đâu thì tôi chưa dám bàn, vì là họ có thể dựa trên cái này để họ tư vấn xem là ở những bạn nào mà có tư duy không gian tốt có thể đi làm kiến trúc sư, kỹ sư xây dựng cái gì đấy. Ai mà có tư duy logic tốt dựa trên cái kết quả phân tích hệ gen nhé thì có thể đi làm nghiên cứu hoặc đi làm một cái luật. Ai có thể chất tốt thì có thể đi làm vận động viên hoặc là công an, cảnh sát. Độ chính xác thì chưa biết đến đâu, nhưng mà riêng về cái tuyển chọn vận động viên ấy thì là có cơ sở khoa học. Vì là tôi nhớ cách đây khoảng độ 2-3 năm thì tôi có được tham gia và nghe một cái dự án của bên Bộ Thể dục Thể thao về tuyển chọn vận động viên dựa trên gen. Và cái này là có cơ sở khoa học, bởi vì là trong các gen của con người có một gen tên là gen Actin-3. Thì cái gen này mã hóa cho cái trypsin là cái thành phần cấu tạo chính ở trong cơ. Qua chúng ta học rồi, đúng không? Qua vừa mới nghe xong là gen thì biểu hiện lên protein, và protein thì qua cái quá trình post translation modification tạo thành các cái protein, đúng không? Protein mà bị đột biến thì sẽ tạo nên chức năng khác. Thì trong quần thể có một số người bị một cái đột biến này làm thay đổi cái amino acid số 570 mấy tôi không nhớ, biến đổi thành stop codon. Cấp 3 biến cái amino đấy thành stop codon, có nghĩa là polypeptide là dừng tổng hợp tại đấy luôn. Cấp 3 thật rồi, đúng không? Stop codon thì nó là cái gì đấy rất là ghê gớm, rất là kinh khủng, gây cho protein biến tính, nó gây cho protein mất chức năng đủ các thể loại. Nhưng mà riêng ở gen Actin-3 này thì có đột biến này tạo thành một cái protein cấu trúc mới. Và protein cấu trúc này khi ở trong cơ của vận động viên nó làm cho cái cơ của vận động viên tiêu thụ năng lượng một cách hiệu quả hơn, nhanh phục hồi hơn và khiến cho vận động viên là lâu mệt, sử dụng năng lượng hiệu quả hơn và ít chấn thương hơn. Thử xem một cái clip về
cái này đây rồi. Cái mát ghi lê này.
Xuống nữa đi. Xuống nữa. Đây.
Không, cái đây là có mét thôi.
Không
Mét.
kia, bên phải.
Đây.
Nó tương tự nhau nhưng mà bên phải biết đầy đủ.
Không có.
Nhìn đi.
Recently, I had my
Không nhớ là có.
just of the XX.
Đấy. Đi tìm chữ M.
Recently,
Bên này là AU.
I chose 23andMe because they highlighted which variant of the ACT entry gene the user was
Cái
in
đó là mét đây.
Ừ.
Mét là có một cái rồi.
So
Cái
the
đây là cái mét
ACT
không?
entry gene codes for a protein known as alpha-actin 3. Alpha-actin 3 is a structural protein found only in fast-twitch muscle fibers. Now when a gene codes for a protein, it goes something like this. A gene or genetic sequence made up of a series of letters known as nucleotides, which are A, T, G, and C. These letters are laid out in a specific order. Cellular machinery reads these letters and makes a variety of amino acids. These amino acids are then assembled into the protein the gene codes for, which then makes up the specific structure in your body. Now in the general population, there's a mutation known as R577X. In this mutation of the ACTN3 gene, a single letter, C, is replaced with a T. This replacement drastically changes the outcome of the gene. So instead of an arginine produced, a sequence that codes for stap production is read. What this means for you and I is, depending on your particular variation, you may possess a much lower percentage of fast-twitch fibers. When you're born, you're made up of both of your parents' DNA. Each of your parents donates a copy of their genes, and depending on which copies of the ACTN3 gene they possess, you may end up with either 1, 2, or no copies of the functional ACTN3 gene. The functional copy of the gene is designated R. The mutated version is known as X. If you get 2 copies of the gene, you're left with 3 options: RR, RX, or XX. In 2003, a group of researchers analysed 436 general population non-athletes and 429 elite athletes from 14 different sports. 107 of the 429 were considered power athletes. Of these 107, 32 were Olympians. 0% of the 32 Olympians were in possession of the XX elite. Just 6% of the 107 power athletes had 2 copies of the mutation or XX. So 96% of the remaining athletes had at least 1 copy of the functional ACTN3 gene, so RR or RX. This would beg the question, do we see a corresponding drift in the opposite side for endurance sports? Do elite endurance athletes hold higher percentages of the XX elite? In our original group of 429 elite athletes, 119 were considered endurance athletes. Just 24% were in command of an XX genotype. Researchers in 2014 asked the same question. Investigating East African runners, they determined an ACTN3 deficiency did not suggest endurance performance due to its very low variance among these populations. The implications of possessing the R557X variant don't just have potentially poor performances across sports, but they also seem to put the player at higher risk for injury. In 2019, 257 male professional Italian football players and 265 non-athletic controls were analysed. They assessed structural injuries and functional muscle disorders from 2009 to 2014. And in quite a stark realization, XX players held a 2.66 times greater chance of an injury incidence compared to their RR counterparts. For just injury incidents alone, RR and RX had similar rates. When we looked at severe injuries, the RR genotype pulled ahead of both the RX and XX groups. The XX group had 2.13 times greater chance of severe injury compared to the RR, while the RX had a 1.63 times greater chance of severe injury compared to the RR. It's possible these injury incidences could differ across sport domains. 89 Spanish elite endurance runners were divided into their genotype, and injury rates for 1,000 hours of running were scrutinized. RR athletes had the highest number of injuries with 3.2 or 1,000 hours of running. XX came in second with 2.2
còn
Injuries per
cái mà ví
1,000
dụ A lớn A
running,
nhỏ thì là
and
hai cái
finally
khác
the
nhau,
RX
đúng không?
came in at the
Nên
lowest
mình
rate
đánh
of
lẻ từng
injuries
thằng
with
chưa.
2.0
thì
injuries
thực
per
hiện là
1,000
A nhỏ
hours
nhỏ
of
nó
running.
sẽ bị
In one fashion, this might make sense,
khả năng bị sặc
as you're forcing your body to an activity that it
Ít
might
hơn đi
not
nhỉ?
necessarily be
nhiều
built
hơn
for. It
Nhiều
may
hơn
be
á.
overloading systems that are designed for very
Đây là
different
do vận động
behaviors.
viên nó dính chấn
May
thương chứ
also
đâu
simply
phải
be
là
a
do
limitation
đâu.
of the study. 42% of the total athletes were RR, whereas the XX group were just 18% of the sample group, which interestingly reflects the general
Nhưng mà chắc chắn là
population who
ai
seem
nhỏ
to have the
hiện tại
XX
thì
gene.
nó nhỏ.
There may simply not have been enough XX athletes to provide a meaningful result, considering other data. ACT and trees influence doesn't stop at injury rates. It also seems to play a meaningful role in muscle damage, hormone, and inflammatory responses. Blood samples were taken pre and post eccentric training from 37 pro soccer or football players. Post training, XX athletes presented higher levels of creatine kinase, alpha actinin, and cortisol. Our RR and RX athletes presented higher levels of testosterone and interleukin 6 after training. Of course, more testosterone, more better, and in this case, interleukin 6 or IL-6 acts as a myokine, which is associated with better muscle growth post-training. Long study short, our XX athletes presented more muscle damage and ended up in a more catabolic state after training. In day-to-day living, the R577X polymorphism doesn't present itself with any disease traits or what would be considered inhibitory to normal living. Individuals with this mutation have higher levels of alpha-actinin 2, which likely compensates in many of the non-extreme physical cases. Some differences may present themselves, however, and may become apparent as research continues. A Tokyo-based study recruited 1,257 participants for a grip strength and sit and reach test among general population. The RR group was significantly lower in their sit and reach abilities compared to the RX and XX group, even after adjusting for variables such as exercise habits and sex. The ACT entry may also play a role in trainability or responsiveness to training. In a group of 120 well-trained men and women, repeated exercise bouts proven an increase in peak torque in a 30-second wind gate test as the test progressed in the RR group, but not in the XX group. It's an incredible idea that the gene coding for structural protein could be a key player in training response. It's possible in the future we could imagine a world where training is influenced by your genetics. Long story short, when selecting volunteers for the CPSAN Select National Power Team Master Sport Team, looking for the RR allele will likely be very high on the list of priorities. So which copies did I get? Well, you don't snatch, grip, or jerk 200 kilos with an X in your genotype. Thanks.
tôi có thể đưa tạo mẹ để làm gì thì làm nó vậy.
Đưa gì không?
Ok, xin lỗi, vậy là hơi nhầm lẫn một chút. Như vậy là cái đột biến X thì sẽ dẫn đến cái việc vận động viên tuy rằng là có sức bền tốt hơn các vận động viên khác, nhưng mà khi lại không có cái sức là cái sự tăng tốc của cơ trong một cái khoảng thời gian ngắn tốt bằng các vận động viên khác. Như vậy là kể cả cái nghề, kể cả vận động viên thì nó cũng có rất nhiều cái ability khác nhau. Có những cái vận động viên thì nó cần một cái sự, ví dụ vận động viên chạy cự ly ngắn thì nó cần một cái sự tập trung, một cái sự sử dụng năng lượng hiệu quả, cơ sử dụng trong một khoảng thời gian ngắn. Tuy nhiên những vận động viên liên quan đến chạy bền, chạy khoảng cách xa thì lại cần cái sự bền tốt hơn, đúng không? Alright. Nghiên cứu về gen người nhiều cái hay lắm. Có những cái gen liên quan đến việc là người ta thích ăn đồ ngọt. Đây không biết bạn nào thích ăn đồ ngọt không? Người ta nghiên cứu là có những người thích ăn đồ ngọt nhiều hơn bình thường. Liên quan đến một cái gen mà mình quên tên rồi. Khái cái gen đấy mã hóa cho cái thụ thể trên vỏ não. Người bình thường khi mà ăn những đồ ngọt thì tế bào trên vỏ não nó sẽ tiết ra dopamine làm cho con người cảm giác thỏa mãn. Tuy nhiên ở những người có gen thích ăn đồ ngọt thì nó sẽ có nhiều thụ thể hơn, và dẫn đến cái việc là người ta có cái cảm giác thỏa mãn, người ta cảm giác sảng khoái khi ăn đồ ngọt nó nhiều hơn rất nhiều so với người nữa. Dẫn đến việc là cái thôi, chém gió tí buổi sáng lớp đỡ buồn ngủ của bạn thì nó đông đủ hơn. So on the type of genetic mutations, we have two levels. Like we have all studied in high school, so I'll grab in this part very quickly. Two levels. In the first level, in the DNA level, we have DNA mutations. Then in the high level, in the chromosome structure and chromosome number, we have the chromosome mutations. So I have a small comparisons
Nó tự
between
nhiên nó như này mà.
DNA mutation here. DNA mutation is defined as alteration
lâu
and
chưa vào Facebook.
normal in a nucleotide sequence. Meanwhile, chromosome mutation is the alteration in the structure or in the number of the chromosome. The mutation, DNA mutation is happening more frequently than the chromosome mutation. DNA mutation is causing by mostly like the UV light will produce the double T mutation. That means when you have a tiny nucleotide, that will be if exposed long time under the UV light, it can produce double T, bring another T in mutation. Meanwhile, chromosome mutation structure is causing mostly by an error in the crossing over or in the splitting the double chromosome in meiosis. Now, talking about the effect, of course, the chromosome mutation have a larger effect compared to DNA mutation, seen up here to affect the large region of genes, and it can affect many genes belong to the affected gene.
Này tự nhiên nó nói như này.
Đăng ký không đi thì sao? Mà đăng ký
Meanwhile, the DNA mutations normally just affect one gene. Depend on the position. Some was critical, but most of the DNA mutations are benign, which is the DNA mutation located in not very important regions. But when spread into population, I say here, the most affected mutations have been selected out of the population by natural selection. Only the mutation have none effect or have a light effect on the physical trait of the carrier can be spreading out the allele and increase the allele frequency in the population.
Mutation, among ability to fly high in the sky to that of diving deep into the oceans. We all love to have such fantastic abilities, but these are all fictitious. Such fantasies don't exist. So can we say that mutation also doesn't exist? Hold on, that's not true. Mutation does exist. But mutation doesn't lead to such drastic changes in us humans. We can't have mutations that give us extraordinary powers. Rather, most mutations give rise to concern. They result in undesirable changes from time to time. In these upcoming videos, we shall majorly talk about mutation, what causes them, and their types in general. Let's begin with the definition first. Mutation, in simple words, is defined as sudden and abrupt changes to the genetic material of organisms. Now let's break this down to understand it better. Sudden and abrupt changes means a few changes that occur suddenly and are mostly unexpected. These changes are usually random and disruptive to the normal functioning of the cell. And where do these changes occur? They occur in the genetic material of the organism. That means in the DNA. And as a result, either the gene or the complete chromosome gets affected. So mutations are spontaneous changes that affect the DNA or the genes or sometimes the complete chromosomes. Now since these are the areas that get altered, mutations are categorized on the basis of them. The two major types of mutation are genetic mutation and chromosomal mutation. Let us see these types. Let's consider this small section of the DNA. Let's say that this part changes into another. Another possibility is that either this base gets deleted or an extra gets inserted. In either case, the outcome is that the sequence of the gene will change. Technically, the reading frame will change. The ribosome assembly, including the tRNA, reads the genetic code in triplets. These triplets are called codons. Now, if there's any change in a single nucleotide, then the entire codon will change. Thus, the reading frame will change. And what will this result to? That's right. The altered gene will give rise to a different protein than the usual one. And there are chances that this defective protein turns out to be a harmful one. So any change in the DNA or in the genes can cause a shift in the reading frame. As a result, an altered protein is produced. This was the first type. Now let's zoom out of the DNA structure. What do we see? Yes, we see a typical chromosomal structure. Now tell me, what will happen if there are any alterations in its structure? And what if the total number of chromosomes get altered? Let's find the answer in the next part. This is a representative karyotype of a human. By now we know what a karyotype is. Can you try to give me some conclusions of it? You may say that it looks perfectly normal. But let me spot a flaw for you. Do you notice this set? This is the 21st chromosome set. Instead of having a normal pair of chromosomes, here we find a triplet. Now you may say that it may be good for the individual as it has an extra chromosome. But that's not the case. Any change in the number of chromosomes creates a lot of defects in the normal functioning of the body. On this note, let's understand chromosomal mutations. As the name says, chromosomal mutation means the mutation of chromosomes. And how exactly does it get mutated? It can happen in two ways. One way is where the structure of the chromosomes gets disrupted. The other is where the number of chromosomes are different than the usual in the organism. Let's have a look at each type. This is the structure of a typical chromosome. Now imagine this small part gets physically removed. This would result in the chromosome in getting smaller as its segment is lost. This also means that if the segment had some important genes, then they will also get lost, which can result in severe abnormalities. Such type of a mutation is called deletion. This is where the part of the chromosome gets deleted. Now imagine this part of the chromosome gets duplicated. As a result, the chromosome's length increases. Needless to say, this will also result in some or the other abnormality in the individual. This type of mutation is called duplication. Now comes the next type. These are two different gene segments. Imagine they get flipped. Thus the chromosome will appear like this. This is called inversion. Do you think this type of mutation is harmful? It may or may not be harmful depending on which genes get flipped. Now let's take one more chromosome. Imagine a part of this chromosome gets removed and gets inserted in this chromosome. What will be the result? That's correct. Both the chromosomes will change drastically. This type of mutation is called as insertion. And now comes the last type. Instead of a segment getting inserted to another chromosome, let's imagine a situation where a segment from each chromosome gets interexchanged.
Slide ở tôi.
So this segment will get into this chromosome and vice versa. This kind of mutation also results in abnormalities as both the chromosomes get altered completely. Any idea what this type will be named as? Well, this type of mutation is called translocation. All these mutations resulting in the disruption of normal chromosomal structures are broadly capped under a single heading. They are categorized as chromosomal aberrations. Now this was about the mutations that involve changes in the structure of the chromosomes. What about the mutations that involve a change in the number of chromosomes?
Tối nay không nên nói nhưng mà đại khái
Let's
là
understand that in the next
đêm
part.
tối mình đang ngủ bị tỉnh giấc sau một lúc sau ngủ lại được.
This is a normal chromosome, while this is a disrupted one. When the structure of a chromosome gets altered, it's called chromosomal aberration. We have seen this. Now let's move on to the second type. It's the mutation that involves a change in the number of chromosomes. It's called as aneuploidy. In literal terms, aneuploidy means the presence of an abnormal number of chromosomes in a cell. So the karyotype of a person with trisomy 21 is an example of aneuploidy. The presence of one additional chromosome in the 21st set gives rise to a total of 47 chromosomes in a person.
Gen react ở trong cái
So instead of a normal 46 chromosomes, this person has an additional chromosome. To be precise, an additional autosome. This case of aneuploidy is called trisomy 21. This is because there are 3 chromosomes instead of 2 in the 21st set. The problem of trisomy 21 leads to a condition called Down syndrome. We will get into the details of these disorders in our higher grades. But for now, let's focus on understanding the chromosomal mutations. This aneuploidy involved an autosome. Now tell me, what if the number of sex chromosome alters? So instead of XY, what if an individual has XXY? Is that even possible in the first place? Well, yes. There can be individuals with an additional X chromosome. This condition is called Klinefelter syndrome. Such individuals exhibit both masculine as well as feminine characteristics. Now in the case of females, imagine that instead of addition, there is a deletion of an X chromosome. This would mean XO. So this individual will have only one X chromosome. This condition is called Turner syndrome. There are a few developmental abnormalities in such scenarios. These individuals have a total of 45 chromosomes only. These were a few examples of aneuploidy that involve autosomes and sex chromosomes.
Đậu má không ghi.
Now before we conclude, tell me one thing.
Tôi có tiếp tục.
What causes these mutations?
Máu hương mình-
How can DNA or genes or entire chromosomes get altered?
Viết thêm mẹ xuống.
There are several factors named mutagens which lead to alterations. Some of them include radiation, chemicals, and even certain consumable items.
Nó quay
To summarize, we have 2 major types of mutations.
con đầu ấy.
One which involves alterations in the DNA or the genes. These mutations result a shift in the reading frame, resulting in defective protein synthesis.
Cơ lắm vợ.
Alterations in the structure results in chromosomal aberrations. They can be categorized as deletion, duplication, inversion, insertion, and translocation. The other is where the number of chromosomes are different than the usual in the organism. It's called aneuploidy. The changes can be in the autosomes as well as the sex chromosomes. Here, the total number of chromosomes in a cell are different from the usual. This was about mutations in general. To find more interesting videos, do not forget to subscribe to our channel.
Alright, so in case of the high DNA mutation, that means DNA mutation in the DNA level, we have many types. First,
Lúc thì là
we have in here a normal sequence with the
Như này nhá,
C,
như này
T, A, and G.
Về sau
And
ông
insertion that
hoạt động
an
sinh hoạt một
extra
tắm rửa,
nucleotide,
ăn uống,
in this
ngủ
case
hết,
G,
thức
was
dậy, tỉnh
inserted
dậy,
into the sequence.
đảo giường.
Make the reading
Sẽ
frame
có một bài kiểm tra khoảng
was
70 điểm
changed
tổng cộng,
from the position of the insertion of.
60 câu trắc nghiệm và 10 điểm.
Another is deletion, which is we have one nucleotide in position was removed out of the sequence. We have duplication, where actually duplication is one type of insertion, but in here, instead of insert a random nucleotide, is repeat in a case of here is the CT2 nucleotide for insertion. It's due to error in the DNA replication that the DNA will replicate the CT here twice. So this duplication mutation are very frequent in some disorder like the Huntington disease. We'll talk about, describe more detail about Huntington disease on the next chapter, but in Huntington disease, we will have 3 nucleotides, which is also due to an error in DNA replication, is repeat, and the more it repeats, the more severe the patient will become. And it may brain damage, the damage and neural cell. So the brain of the carrier was on the abnormal state, and it cannot, of course, leading to the intellectual disability, and make the carrier cannot act like a normal. Inversion, which is more rare than the pre-other, but also is type of DNA mutation. Sometimes the position of 2 nucleotides was changed from each other, it's causing the alteration in the 1 or 2 amino acid if these 2 nucleotides are in different current. And last one is a substitution, which is the most popular type in DNA mutation. So this substitution making a mutation called SNP, which stands for single nucleotide polymorphism. And according to the human mutation data bank, we have a data bank for everything. Human mutations data bank. So most of the mutation, 90 of the mutation is SNP, which is stands for single nucleotide mutation or polymorphism. When we call it mutation, when we call it polymorphisms, so mutation is it appears first generations. And so we think that in populations, if the frequency of polymorphisms is less than 0.01%, that means less than one case in 10,000 people, we consider it mutation, and if more, we call it population polymorphisms, because it has been spread out in the population. So, one of the very famous example, you might study this in high school, is the point mutation that causing the sickle cell disorder. So the sickle cell disorder is caused by only one point mutation. One point, one nucleotide in 3 billion base pairs. But it, due to the hemoglobin structure, that it made encoding for the hemoglobin, the main structure protein in the red blood cell, the erythrocyte. That causing the shape of the erythrocyte will have a half moon shape like this, instead of the normal shape, which is like a flake here. So this mutation is causing by only one mutation, RS334. This name is really famous. It changes only the nucleotide A from A to T. And because of this change, the normal amino acid sequence from glutamine changed to violet. So it's made the structure of the beta globin change and causing the red blood cell have an abnormal shape. So red blood cell, the function of the red blood cell is carry oxygen and carbon dioxide in the body. So of course, when the protein was abnormal and thus the shape of the cell was abnormal like this, the cell cannot maintain its function. The fact that carrier with the homozygote type of this SNP, of the mutant allele of this SNP, will be killed, will be eliminated out of the population. However, if we go to the genome data bank and sample, and we study for this SNP, RS334. So we can see in here RS334, which is in the chromosome 11. It's a missense mutation and it's related to the sickle cell anemia. But if we go to the population genetics, we see that these alleles are differently distributed in different populations. In East Asians, in Europe, and in South Asians, 100% is RNT. Meanwhile, in American and especially in African, there is RNA. In African, the RNA is 10%. That means it's quite common in African populations. For example, in Yoruba population, the RNA frequency of A is even 14%. Can you hypothesis why? Why an allele which is really
Đó, thấy
affected
cái
to
tì tì
the
ra tì.
vitality of the carrier,
Đó.
that
Cái hồi chán
most
thì
of the
nó
carrier
lên.
under the homozygous type was killed on both. Still have a high frequency in a specific population like in Africa. Có bạn nào phỏng đoán tại sao? Về mặt lý thuyết là một cái đột biến mà nó tác động thẳng đến cái sức sống của individual, cái sức sống của người mang cái ALN đấy như thế này thì nó sẽ bị loại ra khỏi quần thể, và điều đấy được chứng minh ở các quần thể châu Á, châu Âu, đúng không? Vì là cứ mà con sinh ra mà đồng hợp với cả cái ALN này thì là chết, sinh non chết luôn. Chỉ có cá thể nào mà sinh nhập tử thì mới sống được đến tuổi trưởng thành. Thì thông thường một cái ALN như này thì qua một vài generation là cái ALN này bị loại khỏi quần thể luôn. Nhưng ở đây riêng cái quần thể châu Phi thì vẫn số nó lại tương đối cao, 10% trong quần thể. Đặc biệt là ở một số quần thể như Yoruba đây, tần số đến 14%. Có ai biết là tại sao? Sao? Yeah, please.
I think because this RNA will reduce the infection of some kind of disease
Exactly. So in here, we'll see that
Tâm.
let's go into the phenotype. Go on phenotype data and we'll see why. This question actually made the scientists curious for a long time
Hồ sơ sinh
until
nhật thì
they
ví dụ mà nói về
discovered
ngoại ngữ thì có tính rồi là what the fuck nó làm gì đấy.
that beside causing
Đây là cái
the
bàn.
Phải cứ kỹ sư tương lai à?
Đây là cái bàn tôi mới có. Ủa, là
beside causing the
người sẽ thế nào đây?
sickle cell is play a protective role against malaria, which is largely epidemic area in Africa.
Cái trước đi rồi.
So, in a normal population like in Europe, there's no mosquito, no malaria, no
Nhưng mà
dengue.
tại sao lại xếp bàn như kiểu hình chữ L thế?
So the story is follow the normal way.
Ví dụ cái bàn chữ L
The
này này
population,
đây rồi cái này để
the
tính ạ.
mutant allele was wiped out of the population because it affects to the vitality of the carrier.
Thế sao không
The
làm
carrier
cái bàn hình chữ U
and the
đi?
sickle cell have a lower chance to passing through this allele to the
Chỗ của
population.
tôi là nó. Đây là cửa sổ.
However,
Đây là cái bức tường không.
In Africa,
Chỗ này, ở bên này.
because this is deeply malaria affected epidemic area,
Thì hồi trước
So,
có chỗ nhà thế là
where
có
the
hai cái bàn,
mosquito
một cái bàn.
Thì hồi trước
put the
đây
malaria parasite in the bloodstream of the
là
carrier,
góc tường.
it will follow and it will
Hồi
infect
điện
into
rồi
the
là
red
đây.
blood
Và
cell.
cái bàn này ở đây.
However,
Như này.
it cannot or it have a difficulties in affect and inject into the sickle cell anemia. So, in this case, the sickle cell anemia is a protective role against malaria. So we see here in this case, depend on the environmental factor. The beneficial allele could be changed, right? And it
Mic thấy rồi.
internet connection is really bad. So in this case, the protective role of, or what is the beneficial allele could be changed role when the environmental factor will change. Like in the case we have here. So in here, the allele is related to the ability to synthesize melanin in the skin. But in the north, while the exposure of the UV light is not high, so the body needs a certain amount of vitamin D to develop for development. Then the RNA is taken priority because in this population, due to the environmental factor, the RNA is a beneficial allele. Meanwhile, in these region we have a high sunlight exposure, people tend to have more dark skin to prevent against skin cancer and better synthesize of folate. Then the RNG is a beneficial allele, right? So another mutation is friendship mutation, which is the insertion or deletions, the number of nucleotides that cannot divide rapidly for tree. So in this case, the reading frame was totally changed from the positions of the mutation. For example, in here we have a friendship mutations which is happen in here.
Mono liên tục này.
In a normal sequence, we have the DNA sequence is ATG, GAA, GCA, and CPG, which is encoding for the corresponding amino acid. However, a mutation happened during the DNA replications. The DNA was replicated wrongly and take one nucleotide G out of the reading frame. So now because the G has gone, we have the reading frame will change from GAA to AA, and it takes also another G behind here. So AGG, next nucleotide is CAC, and so on. The consequences is the whole amino acids will change from the side the friendship mutation. The location of the friendship mutations, and normally this mutation will have a high effect to the carrier, and this effect normally is bad, but sometimes it can be beneficial depending on the environmental factor, like the two examples we just talked previously. Talking about chromosomal mutations. The chromosome mutation can be divided into two types. One is the structural chromosome mutations, and second is the number of chromosome mutations. The structure is affect to the structure of a chromosome. We have several types like deletions, Duplication, inversion, and translocation. Deletion, that we have the part of the chromosome will be. For example, in here, in the short arm of the chromosome, we have 3 regions A, B, C. After mutations, a deletion of the part B was wiped out of the structure of the chromosome. Duplication is we have the part of chromosome was duplicate in the structure of chromosome. Inversion, that means we have part of chromosome was exchanged to each other, and translocation is we have a different with crossing, which is the exchange in the similar homologous called sister chromatic. Translocation is the exchange in the non-hormone regions of the chromosome. For example, in here we have 2 chromosomes exchange part of each arm. So one very famous translocation mutation is what we call the Philadelphia chromosome. Due to the first patient of this mutation was discovered in Philadelphia. Actually, it's a translocation. Part of the chromosome number 9 to part of chromosome 22, and change to the genes CRARL, which is leading to a disorder related to leukemia, chronic leukemia, and sometimes this acute leukemia. With this disorder is a type of blood cancer.
Cái bạn đó.
Sorry, normally I will ignore all the code when I have a teaching, but this is a very important one. Anyway, where are we? Okay, chromosomal structure mutations. So in here we have a translocation, and one of typical mutation you can study in the internet is a Philadelphia chromosome, which is translocations between chromosome number 9 and chromosome number 22. Another type of chromosome mutation is a number mutations. In number mutation, we have 2 types. First is aneuploidy, which is mostly take place most frequent number mutations in the mammalian and in human, in which the pair of
Đây là sắt.
homologous system or double chromosome was failed to splitting in two cells during meiosis 1. And other consequences here, during meiosis 2, we will have a gamet with the number of chromosomes less or more one chromosome in a certain position. Another type of mutations in here is polyploid, in which more frequent in plants, but not really frequent in animals or humans, because mostly this type of carrier cannot survive. It's polyploid in here. The number of chromosomes belong also to the failure in meiosis, but instead involved in one or two pairs of chromosomes. It involved in the whole set of chromosomes, and leading to the consequences that some carrier will have a triploid, tetraploid, or hexaploid. That means that they will have the extra one set of chromosomes, two sets of chromosomes, and in some cases also four sets more of chromosomes than enough. One typical type of aneuploidy in human is the Down syndrome. So the Down syndrome is the carrier have an extra chromosome in the chromosome pair 21, and it leading to the many phenotype related to Down syndrome, which is abnormal shape of skull. So this abnormal shape of skull will make a pressure in the brain tissues, and it's made to the carrier have an intellectual disability during development. Also other phenotype like short, steady hands, some cardiac problems during birth, an abnormal shape of the teeth, and other abnormal features.
As you're probably well aware, our DNA is like this humongous blueprint of information on how to make a human. Usually this massive document is packaged up nicely into a storage bin called a chromosome. Actually, usually we have 46 chromosomes that we use to neatly organize all our information, depending on how you define organize. Each of the 46 chromosomes is actually part of a pair of chromosomes, since you get one from each parent, so 23 pairs. If you wanted to make another human, first you'd have to find someone that feels the same way, and then you both contribute half your chromosomes, so one from each pair, right? 50-50. Now, what if someone contributes one too many? Say dad contributes 23 and mom contributes 24. Is that possible? Yes, and it's the basis of one of the most common chromosomal disorders, Down syndrome. Someone with Down syndrome has 47 chromosomes instead of 46. Specifically, they have an extra copy of chromosome 21. So instead of 2, they have 3. So Down syndrome is also known as trisomy 21. In other words, 3 chromosome 21s. Alright, so in order to package up half the chromosomes into either a sperm cell or an egg cell, you actually start with a single cell that has 46 chromosomes. Let's just say that we're making an egg cell for the mother. I'm just going to show one pair of chromosomes, but remember that all 23 pairs do this. So the process of meiosis starts, which is what produces our sex cells, and the chromosomes replicate. and so now they're sort of shaped like an X. Even though that there are 2 copies of DNA here, we still say that it's 1 chromosome, since they're hooked together in the middle by this thing called a centromere. Okay, now the cell splits in 2 and pulls apart the paired chromosomes. So in each of these cells, you've now got 23 chromosomes. Now the 2 copies of the chromosomes get pulled apart, and the cell splits again, which means 4 cells, each still with 23 chromosomes. Now these are ready to pair up with a sperm cell from dad that has 23 chromosomes as well, totaling to 46 chromosomes. And voila, 9 months down the road, you've got yourself a baby. Now, with Down syndrome, or trisomy 21, a process called non-disjunction accounts for about 95% of cases. Non-disjunction means the chromosomes don't split apart. If the chromosomes in this first step don't split apart, then one cell ends up with both chromosomes and the other gets none. Then the final result is 2 cells with an extra chromosome and 2 cells missing a chromosome. Non-disjunction can also happen in the second step though. So first step goes great and both cells have a chromosome. But if they don't split apart in the second step, then the final result is 1 cell with an extra chromosome, 1 cell missing a chromosome, and 2 with the right number of chromosomes. Now if a sperm cell combines with any of these that have a duplicate of chromosome 21, then the combined cell will have 1 extra copy of chromosome 21. In other words, 3 chromosome 21s, or trisomy 21. In case you were wondering, the sperm could also combine with these cells that have a missing chromosome. If that's the case, then there would be a total of only 1 chromosome 21, and we would call that monosomy 21. In my example, we followed the egg cell from the mother, but this process could happen the opposite way, where the sperm starts out with too many or too few copies of chromosome 21. Apart from non-disjunction, Robertsonian translocation accounts for about 4% of trisomy 21 cases. Translocation, in this case, is a fancy way of saying move from one place to another. So a part of one chromosome moves and switches places with a part from another chromosome. In this case, the long arm of chromosome 21 translocates over to chromosome 14, and you end up with 2 hybrids, one with both long arms and one with both short arms. This little guy with the short arms carries just a little bit of usually non-essential genetic information, and is typically lost by the end of meiosis. So there are a few ways that this can go down. First, including the translocated chromosomes, they replicate. And now these could split into one with both normal chromosomes and one with a long guy and a short guy. In which case, after splitting again, you have 2 normal cells and 2 cells with a big guy. Since remember, we lost the little guy along the way. So now contribute the other parent's DNA, and you've got 2 normal cases, and then these 2 cases are called balanced carriers. And we say that it's balanced because you've still got both long arms, and so most of the genes are still here. Kind of like a 2-for-1 deal. Okay, now let's say that the normal chromosome 14 ends up with the short, and normal chromosome 21 with the long. Now you get 2 cells with the normal and long arm, and 2 cells with the normal and short arm, which remember is usually lost. So these have 1 extra chromosome 21, since the long arms carry most of the genetic material for both chromosomes 14 and 21, and these ones are missing
Tôi nghĩ
chromosomes.
là cái sinh
Now combine these with the other parents
cái
again.
sinh này mình
You have
làm đủ qua
trisomy
rồi.
21
Bây giờ
here
tôi nghĩ
and
bây giờ cũng sẽ
monosomy
phải tập trung
21
tư
here,
pháp.
since it's missing a chromosome 21.
Tại vì là tôi thấy cái sinh
If this process was switched such that chromosome 14 ended up with the long chromosome first,
tôi
then you'd ultimately end up with trisomy 14
nên là tôi nghĩ
and
là nó cũng
monosomy
nên tập hợp
14.
tư pháp bởi vì sau này ví dụ
So of
là
the
trong
12
trong
possibilities, 2 end up being trisomy 21, right?
nếu mà bây giờ
With Robertsonian translocation, one of these chromosomes needs to be chromosome 21, right?
và được phủ điểm
Even though the other is usually chromosome 14, it can actually be other chromosomes as well, like chromosome 22.
mà ông học được B2
Finally, about 1% of patients are mosaic, meaning that their cells are mixed, and some have 46 chromosomes and some have 47.
ông ngồi chơi thấy
How does that happen? Well, let's think about what happens after
bây
conception.
giờ ở đấy
So you've got this one cell called the zygote, that needs to develop into a human, right?
trong series.
Since we aren't single-cell
Trong series mà tự nhiên
organisms,
nó
it has
Vì
to
có tiếng Pháp
divide
cũng kinh nghiệm.
over and over again, essentially producing every kind of
hai
cell
ba
in the
ngoại
body.
ngữ.
Now, each of these divisions is called mitosis. Non-disjunction of chromosome 21 can also happen during mitosis, in which case you end up with one cell that has an extra chromosome 21 and one without. So one with 47 total chromosomes and one with 45. The cell with 45 chromosomes isn't able to survive, but the one with 47 does survive, and continues to replicate and produce more cells with 47 chromosomes. If this happens early on in development, then you can imagine that a lot of cells down the line can have 47 chromosomes, right? If it happens later on, then less cells will have 47 chromosomes. Mosaics can also happen when the zygote starts with trisomy 21, or 47 total chromosomes. In this case, non-disjunction would produce one cell with another extra chromosome 21. So this one has 4 chromosome 21s, totaling to 48 chromosomes. And this cell can't survive. The other cell, though, loses one of its 3 chromosome 21s. So now it only has 46 chromosomes, which happens to be the normal amount of chromosomes, right? And this is sort of like the opposite situation, because now, through a mistake, you actually ended up with the right amount of chromosomes. So if it happens early on in development, you'll actually end up with more cells with the normal amount of chromosomes. If it's late in development, though, then less cells will have the normal 46 chromosomes. Having an extra chromosome 21 is one of the most common chromosomal disorders, and not surprisingly, it has an effect on almost every organ system in the body. And for that reason, there's a long list of common issues for those affected with Down syndrome. Here are some of the major ones. Septal defects in the heart's chambers, usually between the 2 atria, duodenal atresia, increased risk of acute lymphoblastic leukemia, mental retardation and an increased risk of Alzheimer's, and sterility in males. There are several physical characteristics as well, like a simian crease in the hands, a gap between the first 2 toes, a flat facial profile, and epicanthal folds. Having an extra chromosome 21 is thought to affect these systems by an overexpression of genes on chromosome 21, since there's an extra copy contributing to gene expression, which changes the development of all the systems just listed. Now, a major risk factor for Down syndrome is maternal age, the age of the mother. Trisomy 21 happens about once in 1,500 births, where the mother is younger than 20 years old. Contrasted to about 1 in 25 births, when the mother is older than 45 years old. During pregnancy, some screening tests can be done, and certain markers suggest higher risk that a baby might have Down syndrome. Alpha-fetoprotein, or AFP, unconjugated estriol, or UE3, are on average lower when compared to unaffected pregnancies. And human chorionic gonadotropin, or HCG, as well as inhibin A are both typically elevated compared to unaffected pregnancies. An imaging test using ultrasound can also be performed, where clinicians look for nuchal translucency. None of these are exact indicators of Down syndrome, however, but they do give valuable information about the overall risk of Down syndrome. Even though there's a long list of complications and hardships for people with Down syndrome, improved medical care has led to a much greater longevity and quality of life. Many individuals with Down syndrome are able to thrive and lead full lives. Thanks for watching. You can help support us by donating.
Okay, so now we will have a short break, 5-minute break before we go further in our session. Okay, 5-minute break.
Này. Getting mad.
Cắt nước đỡ chịu được. Đây.
Tôi phải đi ăn. Tôi phải đi ăn sáng.
Xuống mua hộ chai nước lọc rồi nhá.
Không, tôi đi ăn sáng luôn ở đây này. Tôi mua rồi. Tôi để ở trong con bàn.
Ôi à. Hay là có uống matcha không?
Không, tôi không uống matcha đâu. Hôm qua tôi uống matcha xong tôi bị say đường ạ, sợ. Đi lấy nước đi. Lấy nước đi. Không đi lấy nước không uống. Vâng.
tụi được.
Cái tai nghe công ty
Điên à.
Nó vào với tao biết thế.
What the fuck?
nó nói thế tôi biết thế.
Nói thế á? Đây này cái lần cuối mà nó chat này đây này. Từ lâu lắm rồi. Đây nha, tức
Nhưng
là
mà nó bảo là
đâu rồi? Đây này.
đấy, rồi nghe.
So in this case here, we
Được,
have
quay
a
lại.
failure in a separate in the
Rồi quay
separation
Hả?
quay
of the
lại.
gender
Đấy,
chromosome,
để cho
which in here we have only one gender chromosome, X. Normally, the similarity in chromosome Y will leading to the
Đây,
that
quay nó
immediate death of the cell because
nên
normally the
có nên bỏ bớt mấy cái này
X
không?
chromosome
Kiểu
was
như thế
carrying
nếu mày
many,
lúc ngồi dậy cái thứ đạp phải rồi.
genetic
Chỗ nào?
information, genetic instruction compatible with Y chromosome.
đạp vào chỗ nào. Đấy,
However, the Y0 is that but the X is survived. So we will have a Turner syndrome with the
đây.
many
Cái này
different
rộng bao nhiêu để mày tính
phenotypes
mày
like
nó trượt xuống rồi.
short status,
Tôi nghĩ
abnormal of the cardiac development,
19
Như này.
and of course affect into the
là tầm như này,
ability to producing gain.
Hơn cái cái kẻ.
không tầm như này luôn.
Another
Có
one
cái
is
kẻ ở đấy không?
Không.
happen is as gender chromosome is Klinefelter syndrome,
Tầm này luôn.
which is a failure that
Tầm
separate during meiosis one leading to the
3,
carrier
4,
have two types
chưa
of
đến 50.
chromosome X and
Đây là chưa
one
đến 50.
chromosome Y.
Rồi một
So
mình.
with this, even they have more information than normal, they
Thế thì
also carry
nhà tôi
on
có
also
hai cái bài.
abnormal in developing intellectual disability,
70.
Các bạn là một
the post-statute.
ngang tầm này,
However, this post-statute is
ngang tầm này.
correlate with the low development of the muscle tissue
50.
and of course
Chỉ đủ để
not
tính.
ability to
Nhưng
produce
mà từ lúc có cái lab này về là cũng không ngồi bàn mấy toàn
And
trên
the
giường,
last one
ở trên
is
giường sáng nó khoanh tường cái chân.
syndrome that we
Hạn
discussed
chế
today is
hạn chế
triple
cho lát bị
X.
nóng này. Để trên đùi lên.
So in here we have also a failure in meiosis 1, but instead of the Y we have another.
Đây là kiểu
So
build.
in this carrier we have three chromosome X,
Hôm
which is
hôm
leading
đó là trả
to
cho
the post-statute,
cái tai nghe.
but also the disability of producing gain. So this is a table of type genetic mutation we have in
Xong rồi sẽ có một
in
cái
DNA
cái
level
đồng thời của
is
mình.
insertion,
Cái
deletion,
cái tủ
replication,
thường,
inversion, and
tủ đầu thường
substitution.
có bánh xe.
And
Điều
in
lúc
the
đấy.
chromosomal mutation.
Mẹ hóa ra như thế à?
So we
Tại vì
have
hồi trước
mutation
tức là hồi trước là có mấy lần tôi nấu tôi nấu ăn thì đem qua bình thường là bọn nó thử thì bọn nó ăn các thứ đúng không? Nhưng mà sau tự nhiên nó tự đem qua trong tâm nó cứ liều liều nó như kiểu bấm nhận hại
less or more, one or several
đấy với lý do tại sao
Đang
chromosomes.
kiểu cháu Long với tôi.
And
Tôi vì lỡ
particularly
cháu
when
Long
you
phim.
have when the carrier have an extra size of
hóa ra là như thế à?
Mong
Thế bây giờ mình phải thành
So
kẻ
now
xấu
let's
thì mới
discuss
phải thành kẻ xấu
a
thì
more
mới nói chuyện
interesting
được à? Hay sao?
point,
không
which
xin
is
lỗi.
Xin lỗi nhá.
Hoặc là bên hai làm lành.
discuss
Bây giờ
now
xin
discuss
lỗi.
about the genetic mutation
Nhưng mà mình xin lỗi vì cái gì chứ
after the
mình có làm sai
scope
đâu.
of evolution.
Cái đây nó tránh mình bây giờ.
So Darwin is the one who
Không thể
laid
là
down
sao
the
thì
theory
đang
of
nói
evolution.
chuyện với ông. Giờ bây giờ ông Hạ nói chuyện.
And
Không
when
biết được.
he traveling, he see that there is
Mẹ chết.
a significant evolution, significant related between species.
Chứ đừng có đăng lên.
Phải đăng chứ.
And he draw a cladogram in his left note. For example, the cladogram is a series of species that have relations to each other. For example, in here we have some fish species. If the fish grow along, we have salamander, create another claw on it. We have lizards. We have lizards have developed fur. Mammals gland is feeding the offspring. We have mammals, and mammals have opposite tongue, and of course, equally to another features, it is going to a chimpanzee. But just a cladogram is using to categorize which species are close to the other species. So now, let's have a small exercise to reboot your brain. So from this example of the cladogram, could you help me to draw a cladogram with these 6 fictionary species? Please. So we can see that which species are the closest with which species on this hierarchy cladogram.
So this is my opinion. So I think the closest species B is closest to F.
B is close to F.
Yeah. E is closest to.
So F is closer to which one?
F closest to C.
C. All right.
Okay. And C is closest to E.
Yeah. All right.
E is closest to D, and D is closest to A.
So we have the order is the first one. A is close to D because A is D is just different in the eyes. Okay. If D grow eyes, it will become A. The golden eye is become D. D is close to E because E is different with D is in the front. Right. So let's see. Consider this antenna say is the front.
Không có cách nào cả.
D grow further.
Theo như bây giờ tôi thấy nó không có cách nào
Each
cả.
grow amount with a carry teeth in here is become C.
Tại vì là
C
căn bản là mình không có lỗi.
grow a few more
Mà cái này là
from
đúng
up, and
cái vấn đề ở đây là do thằng Tâm tự ái. Mình phải giải quyết cái tự ái đó mà mình không thể giải quyết được. Bởi vì là bây giờ ví dụ mà mình mà nói là ấy,
So
coi
the
như là thành
cladogram
như
is
mình giả tạo.
A, D, E,
Mà trong khi mình lại
Okay. Not very difficult with this exercise. However, based on the phenotype trait, sometimes it's really difficult. This is a fictionary exercise. It's easy. But can you draw a cladogram for me
Mấy cái trường hợp kiểu này thì
with
Lan
these
giải quyết
6
được.
species of tiger
Mấy trường hợp kiểu này thì
based
Lan
on your cycle?
thời gian giải quyết tất cả.
điên rồi.
Trường hợp kiểu này thì
Ông thằng Tâm nó nói, thằng Tâm nó từng nói với tôi là
The same exercise with the previous one. Draw a cladogram
nó đã
with
ghét
the
ai
phenotypic trait
thì nó sẽ ghét Tân.
of these 6 species.
sao nó nói được câu đấy với mày và không nói với tao? Tôi chưa nghe được câu đấy từ miệng của nó. Thật, chưa nghe.
Tại vì là nó bảo là có khi là nó giống tao ở nhầm đâu.
Chẳng biết thế. Chúng nó cứ mặc dù là
Which one is
nó
closest to which
nó
one?
nói là nó nói trong đoạn nó nói với ông bảo là anh hùng dương à.
anh hùng chính nghĩa, một kẻ ăn cắp như tôi không thể nào sánh vai với anh hùng chính nghĩa.
Tao có nói nó ăn cắp đâu.
Nó đâu mấy?
Hả?
Nó nói thế, tôi biết thế. Đừng hỏi tôi.
Can I borrow your?
Hay trưởng ạ.
So I see this one.
không
is
biết.
closest to this one because I
Hay
see
là
this
thằng
tail.
Dương, thằng Hiệp, thằng Tâm nói hết.
Tức là cái hồi mà tôi đi với nó là nó nhặt được cái tay em màu đen đúng không? Tôi bảo là có khi là nên trả lại đi đem xuống phòng công tác sinh viên này. Nó bảo là bây giờ nó nhặt được là của nó thì nó dùng, thì bây giờ nó có lần tôi cũng nhặt được thì tôi mới chụp khoe với nó. Sau đó lúc đấy là trong lúc ngồi ăn đấy, bọn ấy bảo là cứ đưa được cho tôi, có thằng bọn nó cứ dụ là đưa cho bọn nó đấy, nhưng mà tôi bảo là thôi cứ để từ từ là may mà có người hỏi để tao trả lại. Sau đó có người hỏi thật, tao trả lại, có thế thôi.
Thì có thể, đây nó là có thể nhé. Giống như tôi ấy, hay bị lỡ miệng ấy, chú rể giao tiếp là có thể trong lúc mà
Any other
ông ấy
solutions?
nói đi cạnh nhau là ông đã lưỡi miệng làm cái gì đấy, nói cái gì đấy,
Any other
ai biết được,
solutions?
ông ấy không biết đâu, không nhớ đâu.
Because
Ông
he
nhớ thì tôi
based
cũng không biết nói gì, tại vì tôi
on
cũng
the
có vài
same
lần
tail.
cũng bị kiểu đấy.
But
Chẳng hạn cái vụ
in the
tôi
other case,
là
the
nó
title
đã
tail
tiền
can be
trong
changed when it's moving.
vòng một khu
And someone is based on the long of the neck, if based on the long, the length of the neck, sorry.
Cái đầu
The length of the neck, so this one is
bây giờ
my
mình không thể giải quyết được gì.
this one and this one also.
Về
because
sau đi hỏi chuyên gia.
three other have a
hỏi
very
chuyên gia
long
đi,
neck.
hỏi chuyên gia đi, tôi không phải chuyên gia, tôi đã bảo hỏi cho tất cả, tôi
So-
đã dạy tôi tiếp chịu.
Based on phenotype features, sometimes it's really difficult to draw a cladogram to see which species is close to another one. But luckily, nowadays we have a more powerful tool, which is a DNA tool. Now, for example, in this case, we have a sick type of fish with a mutation. So, like I said, mutation appear in one individual, and if it not affects seriously to the vitality of the carrier, it will spread out in the population. So, based on the type mutation,
Cái hôm
based on the
lút này
number of mutations,
đây
one species sharing with each other,
đây nhá.
we can draw a cladogram, which is considered a tree of evolution. So, for example, in here,
Có phải là ông thấy mấy bài
we
này
have
khó nhất
6
không?
species of fish.
Thầy đéo
We
chưa?
align it
Đấy,
to see where is mutation appear.
lên lũ
And you see that in here,
mấy cái đoạn
the two
liêm liêm này này. Đấy, sau đó
last
mấy cái này
one
cũng không làm.
carrying no
Thầy
mutation.
chữa đi ạ.
Okay?
Thầy không chữa.
So these two species is close to each
Thầy
other.
chữa kiểu thầy
This one have
tôi nêu
three mutations,
tôi vì thầy không buồn
but it doesn't carry the deletion which is sharing by these three
xong
ones.
rồi
So
thầy bảo một
we
kiểu
can divide this tree and one group, and this
nhá,
tree is
đây là
one
cái
group
màn
Chỗ
chiếu
based
chỗ tao thì
on
thầy
the
đi ra ngoài.
deletion
đây này,
on this
đây
tree.
đây để bài không?
And
Nhìn mày
are a couple of features. So for
đây để bài
example,
không?
this
Thầy
one
biết
is
đây,
sharing
biết
the
xuống đây, biết
deletion.
xuống đây, biết đây,
But this
biết
one
xuống đây.
is almost
Biết là
like
biết xuống đây.
one here, so this
Xong rồi
one
thầy kiểu ngược mặt lên kiểu
can
em
be
hiểu gì? You understand?
close to this,
Xong rồi thầy skip.
the branch here more than the two others.
Có chữa Mỹ là thầy không chữa hết đấy.
So,
Mà bọn ấy yêu cầu thì thầy không
let's
chữa
come
đâu.
with another example
Tôi hình như
based on a DNA. I have another
Cái
six
này
species
mà chắc là bọn nó không học sinh đâu nhỉ.
không nó sẽ
with a
lúc chưa nghĩ
fictionary
lúc đấy thì nó
DNA
sẽ biết
background, which in here is composed of
Nhưng mà
Family
thầy
blood
lát
type.
rồi. Sao?
Could you, by the same technique that we use on this exercise, draw for me a cladogram based on only on the DNA background of these 6 species, please?
Bây giờ nó xác định rồi. Năm cái năm này
It's difficult,
là không
but
thể
it's
lấy
more
được.
clear evidence
Nên
than based on the
nên là phải
phenotype
tập
features.
trung học tiếng Pháp để năm sau lấy học bổng.
Please, try your best.
gì để học bổng.
Hả?
Tiếng Pháp liên quan gì đến học bổng.
Không, tức là Tức là bây giờ là mình không
I'll
làm
give
lại
you
được
5
nữa
minutes for
rồi
this
đúng không? Bởi vì
example.
điểm mình là chỉ có một vài môn cao thôi, còn mấy môn còn lại là trung bình ấy. Thì là năm nay là không gỡ lại được nữa. Thì là bây giờ là không bỏ đi, bây giờ mình chỉ cần qua môn là được. Rồi sau đó là học cái khác. Rồi còn năm sau năm 2 là mình học để lấy học bổng của năm 2.
Nhưng mà chắc gì năm 2 ông đã lấy được học bổng của mình cả nhé. Cái học bổng dễ lấy nhất nhá là cái học bổng mà
20 triệu.
là cái học bổng mà
10
tổng
triệu.
trung bình tất cả các môn trên 17 2 năm nhất của năm 2. Đấy là học bổng dễ lấy nhất rồi, học bổng khuyến khích học tập. Đấy là cái dễ nhất, lấy nhất rồi. Đối với ông phải làm khóa siêu chít lên tầm kiểu 19 20 ấy. Lúc đấy ông có học bổng khác.
Nhưng mà ý là còn là bây giờ mà mình học tôi mới bảo là tập trung vào tiếng Pháp, mà bây giờ tập trung là được bằng A2 thì năm 2 năm 3 bỏ qua được mà.
Nhưng mà không, ông A2 thì năm 2 thôi. Còn khi mà ông đang năm 2 ông phải lên được B2. Nghĩa là đúng cái tiêu chí của bọn là song bằng sau khi mà nó kết thúc chương trình học. Chết rồi. Tôi có một người nhá, con của bạn mẹ tôi là nó học tiếng Pháp rồi, tiếng Pháp A2 có mẹ luôn, nó B2 có mẹ luôn, nó kiểu giỏi lại luôn, nhưng mà tiếng Anh nó bị lơ ngớ, xong rồi nó lúc ra học tiếng Anh nó biết không phải được tiếng Pháp, xong nó đọc kiểu tiếng Anh Pháp ấy.
Mình học tiếng Anh trước, mình tiếng Pháp hơn.
Nói chung là cũng tếu lắm, nói đúng như sắp cháy rồi, tình hình là nó sắp cháy rồi. Cái phần mềm là tôi yêu tốt đến mức độ mà máy tôi không bị tính quạt không bị tính quạt luôn. Siêu quá, ngon đấy.
Ghê nhỉ, phải thiết kế ảo.
Ảo, không biết là gì.
Any solutions? Any solutions?
No.
Any solutions? Yeah, please.
Ai là người nói?
Going to guess is F,
Sao?
B,
Nhưng
E,
gương mặt mới, gương mặt
C,
mới.
A, D.
F, B, E,
Cái gì rồi?
F, B, what? E, C, A, D. Right. We'll see.
Cái gì rồi?
Nowadays there is plenty of
Nghe ra.
software can help us to deal with this, because if we look at in the eye, we can solve the exercise with 12 nucleotides, but we unable to solve this exercise if imagine this instead a fragment of 12 nucleotide is 3 billion base pair. It's impossible, right? But how the algorithms of the software can calculate this? I'll guide you. So first, let's draw a matrix to compare the differences between A, B, C, D, E, and F, right? And we put in here the number of nucleotide difference in the 6 species. Now, for example, between A and B, I compare between A and B, I see that in A and B there are only 3 nucleotides. Here, which is remarked in red, is the same between A and B. The other is different. So, the other 9 nucleotides are different. I put the number of differences is 9. Okay? The same, I compare between A and C, I compare it, you see that the number of difference between here is only 2, because the other 10 are the same. So I put 2 in here. Okay? And the same, this is the number of nucleotide differences between the 6 species. Okay? You understand this point? Right. So now I will come with the lowest number in this matrix. The lowest number, that means that 2 species is the most closest to each other, right? So what is the lowest number? 2. 2 is the lowest number between A, C, and E and B. So let's say I group A and C as a group, and B and E as a group, because these 2 are closest to each other. Okay? Now I'm trying to decrease this is a 5 and 5 matrix. I decrease it from 5 and 5 to 4 and 4 by group A and C as a group. In here, I see that the distance between A and B is not. The distance between B and C is also not. So, with the new species A/C, I group A and C as species, the distance between B and A and C is also not, right? Because the distance between B and A and B and C are the same now. Okay? You understand this point? The next, the distance between A and D is 4. Distance between C and D is 5. So the average distance between A and C is 4.5, which is the average between A and D and C and D. Okay? And so I do with the rest. I successfully decreased from the 5 to 5 to 4 to 4 matrix. Now, the loop come back to its beginning. Come with the lowest number in this matrix and draw a new cladogram. So the lowest number is 2. Another time I group B and E, because the lowest number is here, I group B and E as a group.
I recalculate the distance between B and E with the other. So distance between B, E and A slash C is 9, and B with A slash C is 9, so the new is 9. Because 9 here, 9 here, 9. Okay? So I again decrease from 4 to 4 matrix to 3 and 3 matrix. So what is the lowest number in the new matrix? Lowest number in here? 4.5. So I will group A, C, and D as a group. Because the lowest number here is 4.5. Yeah, right? So I rewrite the distance is A slash C slash D, and the other is B and E, and recalculate everything. Now I have new matrix 2 to 2. So the lowest number here is 7.5, which is B and E. So I will group all A, C, D, and B and E as group and add new. So the correct number is AC is close to each other, and D. Meanwhile, B and E is another branch, and the last one is up. Okay. So imagine, just know how the algorithm was calculated with the software, and you can apply the software to knowing how it's calculated with sequence 3 or sometimes much more longer. Right? Alright, I think it's finished for today's session. Do you have any questions? Okay, thank you very much and see you next week.
Hơi nhanh nhỉ.
Cả buổi học chiếu 3-4 cái video là xong mẹ.
Đâu, đoạn cuối thầy có